All right. So let me show you graph shifting with trig stuff by example. What was the function we just looked at? F of x is minus 7 cosine of 3x minus 4 plus 17 or something. Okay. So I would like to know what the graph of this thing looks like. So first things first, bubble diagram this sucker, which we did.
Yep.
So you got multiply by 3, subtract 4, cosine, multiply by 7, multiply by negative 1, and then add 17. Okay, so in order to get a graph for this thing, where do you start?
The rule.
Okay, start at the rule. That's cosine, right? That's the thing you know the graph of?
Yep.
Okay, so cosine looks like this dude, right? Where the top is, oops, the top, how high is the top?
1.
1? Oops, so
0,
that's
0,
at 0 and 1. And the bottom down here is at
0, negative 1.
Oh, that one. That one's at pi negative 1.
pi and negative 1.
Is that being purposely slanted or is that?
No, that's just because I was drawing on the bottom of the board. Sorry. That should be horizontal, this should be vertical. Horizontal and vertical should be perpendicular to one another. Not like I have here. So then where do I go to get my picture?
Then you go
You guys remember this?
minus 4.
Yeah, so you got to go through the x's, but backwards. So the minus 4, that should be a what?
Right.
Right shift.
Yep, that's a right by 4. Okay, so I'm going to take that whole picture and scoot it to the right 4 units. So let me do that this way. Let me draw the cosine I had before. I'm trying to do a better job with this one. And now where is this top bump? Good, it's at 4, comma 1. Where's this bottom bump? Pi plus 4 and negative 1. Beautiful. Okay, then what's multiply by 3 do?
Vertical stretch.
Nice try, buddy.
Horizontal compression.
That, I like, multiply by 3
No,
to me,
yeah,
in my
no,
head,
it's
goes
before-
with vertical stretch,
Before
right?
the rules, before the
But
rules.
I'm in X land,
It's before
so
the-
everything's backwards. So it's horizontal instead of vertical, and it's a compress instead of a stretch.
It's before the rule.
So this compresses everything by 3. Okay, so what's my picture look like now?
Shorter.
Shorter and long.
Okay, so shorter, right? So the waves go up and down faster. That one is just horrible. Okay.
Slightly.
Okay, so where's this guy at now? It was at 4, comma 1.
Now it's at 4/3, comma 1.
Good, now it's at 4/3, comma 1. And this guy was at pi plus 4, comma 1, and now it's at
Pi plus 4/3.
pi plus 4 over 3, comma 1.
Negative 1.
Negative 1.
Negative 1. Cool. Okay, so now that I've taken care of the x stuff, what do I do?
Do the y vertical stretch.
Do the y stuff. So I walk over here to my vertical stretch, which is going to change what about that picture?
Make it taller.
It's going to make it taller. Really, it's going to change the y's,
Yeah,
right?
so just
From 1
change-
and minus 1 to
7 and negative
7 and negative 7.
Yeah.
Okay, so, oops, I still shouldn't be drawing this because I still don't know where the heck it is. Okay, so top dot, bottom dot, connecty dots. This is now at 4/3, comma 7, and this guy is at 4 plus pi over 3, comma 7, negative 7. And I don't know why I switched the order. I had pi and 4. Okay, then what? What's the minus 1 going to do?
Flips it over the x-axis.
Flips it over. So instead of having positive y up that way, we're going to have positive y down that way. God damn it. I don't know why I keep drawing that thing. It's just force of habit, I guess. So now we've got something going like this. This is at 4/3, comma, minus 7. And this guy is at pi plus 4/3, comma, positive 7. Okay, and then the plus 17 is going to
Add 17.
lift that whole thing 17 units up in the air. So instead of this being the y-axis or the x-axis, it's now going to be
X equals 17.
the midline, which is going to be x equals 17. Wait, x equals 17?
Y equals 7.
Y equals 7.
Yeah. So,
Okay. So final picture, which I'll draw up here boldly. Oh, we can't reach 17 past that. Final picture, which I'll draw up here, is going to look like loop-d's, right? And this bottom is happening at 4/3, comma, 10.
yeah.
Where'd you get 10?
10 plus minus,
Negative
17
7.
plus negative 7.
Yeah, negative 7 plus 17, right? Okay, and the top here is at
Pi plus 4 over 3.
pi plus 4/3, comma,
24.
24. Cool. And then the important things to note about a shifted trig function are what? What are the things you should be noting?
Oh, amplitude, period.
Amplitude, period, and midline. So midline, 17. Where did the midline come from?
Origin. Of the x-axis.
Midline came from this guy, right? No? Okay. Okay, so the midline's from the vertical shift, right? Okay, where did the amplitude come from? What is the amplitude?
The amplitude is...
It's the negative 7.
Yeah, so the amplitude is the vertical stretch. Why is it not negative 7 but 7?
Because that's the actual value that's being stretched by it, but the...
Yeah, I really only care about how much it got vertically stretched, right? Not about whether it got flipped over or not. So the amplitude's right here. Okay, then where's the period?
So it's positive?
Yeah, the amplitude's always a positive value. It's the displacement from the midline, regardless of sign.
The period is the horizontal compression.
Yeah, the period happened something with the horizontal compression. Did the right for it?
No, to your left.
Oh yeah, it's this guy, the compressed by 3. Okay, so this is where the period comes from, but the multiply by 3 is not the period, right?
Yeah, the inverse.
Okay, so this part tells you that the period is,
2 pi.
yeah, the period you had before, so cosine has a 2 pi period, right? So this 2 pi is coming from the cosine there. And then the 3 contributes a divide because x-land is backwards. You guys all cool with that?
Mm-hmm.
Okay. What is it? Okay, so there's a right 4 and a minus 1 that I kind of haven't accounted for, right? What do those affect?
The horizontal shift.
Yeah, those affect where does this thing start oscillating, right? And
If it's flip.
yeah, does it start going up or going down, or does it start at a max or a min, depending on whether you're talking about a sine or a cosine? Right. For sine, that's a question about does it start going up or going down, and then for cosine, it's a question of does it start at a max or a min. You guys cool with that? So the three things I care about you guys being able to notice are the midline, the amplitude, and this period thing. And otherwise, this is the same shifting rule stuff we did before, right?
What is like the generic formula for that?
Oh, the generic form for this equation, like the category of things we can shift.
Cosine of x.
So the kind of the category of things we can shift around are something like, I don't know, I'm going to call this capital F of x. They're like a and then cosine or sine. A standing for amplitude of some kind of like period adjustment of x plus some kind of shifting thing plus some m for midline. Right, the midline and the amplitude are actually the midline and the amplitude. The p is a little bit funky because it's not actually the period, right?
You could do 1 over p?
Yeah, you could put a 1 over p in here. That would, well, yeah. You could figure out that relationship, right? The new period is going to be 2 pi over p, right? So you could figure out what a more appropriate letter is here, but I would really rather that you thought about that as just a horizontal compression or stretch. I think that'll get you getting it right more often. Also, it's not always 2 pi, right?
Right.
Because you're not always doing a sine or, like in the sine or cosine case, it's 2 pi. But if I put a,
Tangent on pi,
right, if I put a tangent in here or a secant or a cosecant, right, you would have to think a little bit harder. Right? But the same rules would apply. What's the period of tangent?
right?
Pi over 2.
One is right.
It's just pi.
It's pi.
Yeah, because pi over 2.
It goes from minus pi over 2 to pi over 2 with those asymptotes. And so the next section has to be at least minus pi over 2 to pi over 2 wide. That's a total of pi. Cool? Question, thing? Okay.